Hello everyone, welcome again to my channel Learning from Data. Today I am going to talk about skewed distribution statistics. Most importantly, I am going to talk about mean and median, which are the basic statistics for skewed distributions. I guess mostly we are familiar with normal distribution. Normal distribution is ideal. Normal distribution looks like this, which is symmetric on the left side and the right side. But if we have some data points on high side, looks like it has a tail on the right side, we call it a positively skewed distribution. Similarly, if we have some data points on the left side or on the lower side, it looks like the distribution has a longer tail on the left side, and it is called a negatively skewed distribution. The corresponding box plots are shown here. For a symmetrical distribution, the box plot is also symmetric. That means the median, that is Q2, is exactly at the center of the box. But for positively skewed or negatively skewed distribution, the median shifts a bit, and we are going to talk about later on these mean and median positions for skewed distributions. To get an idea about the position of mean and median for skewed distribution, we can look at this figure, which is taken from Wikipedia. For symmetrical distribution, the mean, median, and mode all are exactly overlapping on a single point, like this. But for a negatively skewed distribution, the mean shifts on the left side because many of the data points are lying on the lower side, so the mean shifts towards the tail. But the median also shifts, but mean shifts more. Same for the positively skewed distribution. The mean shifts towards the right side because the tail is here on the right side. Also the median shifts a bit, but the mean shifts more. Therefore, we can say that the mean is mostly affected due to skewness. We talked about outliers before. It is very obvious from this picture that median is not as susceptible as mean because of the presence of outliers. Let's say we have a very extreme data point over here or over here, then the mean will be shifted more. So the mean will be affected more than the median. Therefore, the statistics coming from median are less susceptible than the mean. Let us clarify this case with the help of an example. Here I have a Jupyter notebook open. Here I have a list called A, which has different numbers. Let's look at the mean and the max. The minimum number is 3 and the maximum number is 17. Let's look at the distribution. It doesn't totally look like a normal distribution, but it resembles normally distributed data. Let's look at the mean and median value of this distribution. So the average value is 10.39 and the median is 10.0. That means the mean and the median are very close to each other, which is the case for normal distributed data. Let us append a very high data point. Let's say 100. So I'm appending 100 to list A. Let's look at the distribution again. So here is the outlier, which can be considered an extreme outlier. Let's look at the mean and the median value again. So the mean value is now 14.125, but the median is 10.5. Let's compare these values with this. It looks like the mean has shifted more than the median. That means this outlier has more effect on the mean than median. Therefore, the median statistics are less susceptible to the outliers, which is obvious from these values. The purpose of this demonstration is to show you how the skewed distributions can change the mean and median value compared to a normal distribution. For skewed distributions, we obviously have long tails either on right side or left side, but here I have shown an outlier, and because of this outlier, because of the presence of this outlier on the right side, the mean has shifted on the right side, but the median also shifted, but mean shifted more. This is also true for right skewed data. Therefore, we can say that the statistics calculated from the median are not as susceptible as the statistics calculated from the mean. That's the whole purpose of this video. Thanks for watching.